Welcome to Espresso Electronics, quick sips of video wisdom. I'm your host Anika Sunda and joining me today is Amita Thrissel, Director of GPU Hardware Engineering. Today's topic is very important because we're going to talk about how important are random test benches for flawless silicon. Welcome to the show, Amita.
Thank you.
So, Amita, could you talk about how complex are the test benches and verification environments that you deal day in, day out?
First of all, thank you for inviting me for discussion on this particular topic, which is very important in current days where technology is advancing and we are having cutting edge technologies all around us. Every 6 months or every year, we are having 100 plus new features, very complex. And for that, we need to come up with the test bench where we do focus on random test benches where we have like around 1500 plus random variables. We have thousands of randomization calls. We have a huge regression suite to cover, like around 500K plus random regressions, then 100K plus vector regressions at block level. I'm not even talking about the higher abstraction layer. This is about the block level, and where we deal with huge coverage targets, that is around 2 million plus at least, we need to cover these kind of scenarios. So, yeah, definitely we need to come up with a smart strategy and a very nicely written test benches which can deal with all these complex features and have a proper verification for, as you said, flawless silicon.
So, Amita, all sorts make the world right. I think you will agree that there are people who simply rely on directed testing, right? Or they don't even have any random test benches. What's your opinion on how important are constraints in today's verification environment, right? How important is random verification?
Obviously, you called it out random verification, and we also deal with directed test cases as well, which is equally important because we know exactly what we need to exercise, the scenario wise, what we are verifying. But even though we know exactly what we are verifying, it's not enough. And it's the area where we want to touch upon, and the random test benches are helping us to do that. For coming up with that, like maybe we'll start with everything random, and start verifying. It will become huge, enormous. It cannot complete, it cannot get completed in the kind of verification cycle we have in these days. So we come up with the constraints, and the constraints are nothing but, helping us to set the, design in certain way where we want to exercise all those functionalities. We want to understand whether those functionalities are working properly or not. So we have a state space of the design, and in that whole state space there might be certain scenarios which are very illegal scenarios. We are not interested, project wise doesn't make much sense, so we can cut it down using our constraints. But now with the help of the constraints, then now we have defined another state space where we are actually focusing, which is the area where we want to verify that everything is functionally running correctly. But unfortunately, I don't think any verification engineer can cover the whole state space which is defined by that constraints boundary also, because again it's enormous, and there we use these coverage metrics to understand, okay, these are the scenarios where we are looking at, and that's what I was talking about, the 2 million plus, these. But now what happens is, now we have these constraints. So you might have heard of like loosely set constraints or tightly packed, we have put everything constrained. So what it becomes is nothing but a directed test bench. So we lose out the meaning of randoms. When we put loose constraints, like very minimal, we are being very pessimistic. So what happens? We take enough number of times to cut down, okay, this is not a legal scenario, this is not the scenario that I'm interested in. Certain times, project timelines are such a way that we have very focused, efforts on only few features. So there we want to put in those constraints. Now what happens in that case? Legacy is there. New engineers keep on joining the team, and this is how the things are, and they don't know. So maybe there are certain constraints lying there which are not required for the new project that we are working on. So what we are doing is we are over constraining the design, and by doing that, obviously we will not be able to generate those scenarios which are beyond that constraint, and we can end up hiding a bug. And it's a Murphy's law, whatever we don't verify, bug is right over there. So that is how, these constraints. Now I'm talking about the over constraint kind of issues, right? We do have issues with under constraint also. Sometimes people think, under constraint issues might lead to coverage holes, which we can, figure it out. But that is not the case. We have seen some scenarios where we have under constraint, it never got exercised. That scenario also never got, in there, and we had a bug over there, and we didn't exercise it. There was no coverage metric around it. If you see generally code coverage 100%, functional coverage 100%.
Right, yeah.
That is the max we can do. But there are some scenarios, there are still certain state space which I was, talking about in the beginning, that those state space we have never exercised because it was under constraint. So definitely we have both ways the issue. If we put more constraints,
Right.
over constraint. If we put lesser, yeah, it may take more time, or it may never get exercised and we are still hiding a bug over there. So definitely how we put in the constraints, how we are coding the constraints, that definitely is very important to have an efficient random test bench.
I agree. I think this is a chicken and egg problem,
Yeah.
right? I don't think that there is actually any tool or, like anything very straightforward that exists today that can actually tell you how good your test bench is, right? I mean, is it over constrained? It is under constrained? Is it in the most optimal condition? I mean, how are you doing it today? Like when you are dealing with such GPU intensive test benches, right? How do you do it?
As you rightly said, we don't have a direct, tool or a magic wand, which can tell us, okay, your test bench is a over constraint kind of a thing. So we do manual reviews, and we do it at certain number of times. But trust me, it's so cumbersome, and it cannot still guarantee that we have, identified over constraint issues. One way is to do manual. Another way is to cut down all the fancy constraints that we have after the review that you have figured it out, and then put very pessimistic way, only few constraints. But in that case, again, what happens is design will go here and there, because now we are again changing the direction of the design where it has to go, and traverse that particular path. So what happens, illegal scenarios come, or the scenarios which are not part of that project also appear because of lesser constraints. We do have tool, and in fact there is a tool from Cadence, SimAI exploration solver, which has helped us in profiling our random test bench. So when I'm saying profiling our random test bench, don't take me as a general profiler, like memory profiler or simulation profiler. It is not like that. It is little bit more than that, and it helps in understanding what kind of constraints we have put, what kind of values we are focusing on, exercising on all those random variables, and maybe the combinations also. So that tool has really helped us in doing some, prognosis of the test bench, like to understand where our test bench stands. It may not give you the direct result, but yeah, it can provide you certain scores that you can check after getting that report, and you can analyze, okay, whatever this report says, how good it holds. Do I really understand why I have put this constraint? Even if there is a tool, it is indicating that there is this constraint which is prohibiting certain values to be exercised. But maybe I know very well why I have put that constraint. So that way it's fine. But maybe, yeah, you can get a surprise also later on. So that ways we are using this tool, and it has helped us to a certain extent.
So it's acting a kind of a lighthouse for you. I mean, it's at least helping you see inside the black box, like what is it that's going on inside and how can you.
It's like, as the name also suggests, random. It's random. With the help of these kind of tools, it's no more that random. We know exactly what we are driving. We know exactly what are our goals. We know exactly what are the scenarios we are more interested in, even if they are getting hit for less number of times, but we are interested in exercising them more number of times. So that kind of insight when we get for our test benches through these tools, it really helps in coming up with a better test bench, and it really helps us in identifying the bugs early on in the stage, and also it helps us in faster coverage closure.
Oh, that's wonderful. So, do you want to elaborate a little bit on how did you use the exploration solver in your overall, the methodology in your flow, and then how did it actually contribute to your coverage?
Yeah. So this tool generally works in three phases. First one is the record phase, where it will record all the values which are getting exercised on the random random test bench for all the rand variables. So now that recording is done, that database is all stored, and then the next stage comes is the analyze. So that is the most important, that is the actually crux of the tool, the core of the tool, where it will analyze and it will understand, okay, these are the different values which have been exercised, and it will create a coverage on all the random variables in the test bench, which is like a very cool idea, and it helps us to understand, okay, these are the random variables which have exercised only 80% of the values which were supposed to be there. Now 20% of values, why they are not exercised? Maybe there is a constraint which is blocking it.
Yeah.
Maybe we need to run more tests, or maybe some other reason. But tool will help us to identify those things, and we can go into that analysis. Now let's suppose we have analyzed and we have figured out, okay, there is no constraint problem here. It can still exercise all those rest of the 20%, but it has not because of its random nature. The constraint solvers are like that. They cannot guarantee you all the time, unique stimulus. So what it does is it optimizes, that is the last stage of the tool, where it will take that 20% of unexercised values and make it as a goal, and use it for the next set of regression. And so in that ways, what happens is 100% coverage on those random variables where we were seeing 20% lesser, coverage. So that is how, so the tool is very good in terms of, helping us in faster coverage. And let's suppose we have exercise and that is not it. Maybe we have come up with a test, we are able to exercise, but those tests are failing. So we get the bugs also early in the stage. So that is very important for us from verification point of view. We want more and more bugs getting exposed in early cycle of verification.
That's really wonderful, I think. I think it's making the entire SimAI capability much more stronger, right? I mean, helping you find bugs faster and close your coverage. So, Amita, you spoke about faster coverage, right? Can you explain it through an example? How did the exploration solver actually help you get coverage faster?
Yeah. So we have one example already written over here. Two variables are there, CFG and data1, and we have two kind of constraints for both of them. For CFG variable, we have a distributed constraint where 0 down to 13, these many values are going to be generated most of the times, like 95%, and the value 14 and 15 will be generated for 5% times only. And based on these values, data1 values also calculated based on the constraint that we have written over. So data1 value 2 and 3 will be also exercised lesser number of times based on 14 and 15, which is very 5%. Now when these values, which will be generally when we start our constraint solver, so the more obvious values will be from 0 to 13, and based on this one, constraint solver will also not be generating these two values. What will happen is when we have these goals, so I talked about Explorer, the solver that we have. It works in 3 stages. So recording stage, it recorded that, okay, 14 and 15 values are not hit, right? And these two values are also not hit. Now what happens is, now the goal becomes these values. Goal becomes 14 and 15, so that 2 and 3 will also be exercised. So when we have record analysis, so the analysis is nothing but the goal setting. Now goal setting is for us 14 and 15, which is like 5% of probability of getting them generated. Now with this goal setting, once we again run the new regression, or we optimize it by how we constrain it. We constrain this CFG variable with 14 and 15 values, and that is how quickly we can get to. So we have, in general, the random test benches will have such kind of many these distribution constraints where we know exactly why we are doing it.
Right.
But while doing it, initially we need this way. But maybe later on, towards getting closer to the sign off, we want to exercise all kind of values. So quickly we can just put it in the goals and generate those kind of values. We don't have to tweak the test bench anyways by using the SimAI Explorer.
So it's very easy to use.
Yeah. It's very easy, and this generally this is what tool will do automatically. But even if tool doesn't do, we can define user guided goals with such kind of low probability values and get those exercised.
And do you get good charts and GUI also that can?
Oh yeah, definitely. The
analyze?
GUI around it is very useful, because instantly we can get a lot of these histograms. We can understand, okay, this is the profile, these are the features, because random variables are nothing but certain features we are enabling. So we get to know, okay, these are the features which are mostly exercised. Okay, there is one important feature which is not that much seen. So those GUI is like instant reporting now. One report is a text file, another is the GUI with which you can create all those kind of charts and understand how good your random test bench is, how good all those features are being exercised, and where do you need to focus in the next set of regressions.
So Amita, you mentioned about goals, right? So are these goals set by the tool?
Yes, these goals are set by the tool. That is how the automated way of optimizing the regression results, so that we can go faster towards the unexercised values on the rand variables. But even though Cadence is coming up with this user guided goals as well, where we can provide our own goals with some user input file, where we can also mention, okay, I'm not interested in these goals. So we can discard whatever automatically a tool has set up, or we can say, okay, these are the additional goals that I am looking towards. So that feature is really important, and it is giving some freedom to verification engineers to try out, and instead of always relying on the tool. So that has helped. And only one thing I would say is, right now we are working on with Cadences on cross combination. So right now all these goals are set on the individual rand variables. What we are looking towards is the combinations of rand variables, where user will provide the inputs, and we will have a goal. Okay, this random variable A, B and C, together I want to cover all kind of possible values on these different variables. So so maybe that feature I'm really looking forward to. And also some waivers where a tool is emphasizing too much on certain goals, where I want to waive it off. I don't want to look into those kind of goals. So those also can be really part of our user input goals, which can give meaningful direction to the design, because obviously tool doesn't know the design. So it's we, and we have to take maximum help from the tool to come up with the right set of goals, and reach our coverage goals faster, reach our all kind of bugs which are lying over there in the design faster way. Yeah.
Sounds exciting. So talk a little bit about, what is more to this collaboration? What is, and how are you seeing, the exploration solver evolving?
Yeah. So first of all, I want to see this, these goals from cross combination point of view, and also I want to see when I start using this tool, I want to see my schedule also getting left shifted. because obviously when we bring in a new tool, we talk about a lot of new features and everything. So what management is also looking towards, are we reducing verification cycle using these? So definitely I am looking forward to cut down on the verification cycle with the help of such kind of tools and the ease of the tool. So currently we have this GUI which is very helpful in profiling, like my random test bench is able to generate these different kind of scenarios. So maybe feature wise scenarios, if tool can help me in visualizing those kind of profiles for my random test bench.
So thank you, Amita, for coming to the show, and we are truly excited about this collaboration, and we look forward making leaps together.
Thank you so much for having me.
Thank you to our listeners for tuning in. Keep your circuits connected until we meet next on Espresso and Electronics.